Hello students, welcome to the interesting chemistry where you will find an atmosphere of classroom teaching. If you want to enjoy a classroom teaching experience from your study room, then please watch my video of interesting chemistry. Today I am going to explain you the reactions in solution and these terms molarity, molality, and mole fraction and mole mass percentage. These all terms are related to the solutions. So as you know, solution has two components. One is solute and second one is solvent. If NaCl is dissolved in H2O, then NaCl will be called as solute and H2O is solvent. And the reactions in the solutions, there are so many reactions which are carried out in solution, like acid-base reaction or any other reactions that you perform in your titration, like K2Cr2O7 versus ferrous ammonium sulfate solution, KMnO4 versus, these all the reactions are carried out in a solution form. So here I am going to explain the reaction in solution. So here first of all I have a question for you, that 100 milliliter of NaOH and HCl, when 100 milliliter of HCl when mixed together, what will be the nature of that mixture? Is that acidic, basic or neutral? Can you tell me? What do you think about this question or this experiment? I think that you are unable to answer the acidic, basic or the neutral, because you don't know the amount of the NaOH in 100 milliliter. You don't know the amount of HCl in this 100 milliliter. So without knowing the amount of the substance in a solution, you can't predict whether it is acidic, basic or. But one thing I tell you, if you perform this experiment in your lab with the help of the litmus paper, you can tell me acidic, basic, acid. But you can't explain the reason behind whether it is acidic, basic or without the amount. So amount which is dissolved in a solution plays an important role in the reaction in the solution. So we should know about the strength of the solution, and that the strength of the solution is related to the amount of the solution. If you take the amount more, then the strength will be more, and if you take the amount less, then the strength of the solution will be less. So again, if I take the amount, suppose again here, I take the amount 10 gram per 100 milliliter of NaCl or any compound, suppose NaOH, I take NaOH. Again, I 10 gram in 200 milliliter. 200. So compare the strength of both the solution. Again, the strength of both the solution are different, because the amount is fixed here, but the volume is different. It's 100 milliliter and here 200 milliliter. So the volume of this solvent is also plays an important role to show the strength of the solution. So now here, to show the strength of a solution, you should know the amount. Amount should be in a fixed volume of the solvent, and that amount is, we have decided that the volume of the solvent, volume of solvent will be 1 liter or 1000 milliliter. This is so again, if you have to define the strength, the amount present in 1 liter, so 1 liter of the solvent or in the solution of the solvent, that is called the strength. But now we are coming to this strength. This strength we will say the concentration of the solution. Now we have come to the from strength to the concentration. Both are the synonym of each other, but always say the concentration of solution. What do you mean by the concentration of solution? The amount of the substance present in 1 liter solution, that is called the concentration. If 10 gram NaOH is present in 1 liter solution, then this is the concentration of NaOH. This is the concentration. If 20 gram of NaOH or KOH is present in 1 liter, this is the concentration of the solution. So I have explained you about the concentration, the primary way of show the strength of the solution, that is concentration. Now these terms are also to show, to express the strength of the solution. So this concentration can be expressed in molarity, molality, mole fraction and mass percentages. So I think that you have understood what I am going to tell you about this and going to tell you about the solutions. So I am going to explain you the different ways to show the concentration of solution. So the concentration of solution, that the first is the molarity. What do you mean by molarity? Molarity is, as it shows, the molarity comes from the mole. So when we tell the number of moles that are dissolved in 1 liter solution, that we will call the molarity. So here again, this formula, molarity is the number of moles of solute. Number of moles of solute means number of moles of substance present in 1 liter of the solution. The volume of solution is 1 liter. So molarity is defined as the number of moles of the substance present in 1 liter of solution, that is called molarity. Again, symbol of the molarity 5m, and the unit of the molarity mole per liter. Now if I ask you that what do you mean by 2m NaOH? This is the molarity. This is the molarity of NaOH, because this N shows us the symbol of molarity. Now, if I say to you, prepare a solution of 2m NaOH. Prepare 2m NaOH solution. How will you prepare in your laboratory? So again, you require the amount of NaOH. What amount will you take to prepare this solution? So again, this mole, you can't weigh the mole, you can't tell. Again, you have to weigh the amount in gram. So what amount? As you know, this 1 mole of NaOH is equal to 40. As you know, the molar mass or the molecular mass of the NaOH is 40, and you will multiply this. When you 80 gram of NaOH dissolved in 1 liter, that will be the per liter, you can say per liter, it is show 1 liter, 80 gram per liter NaOH is. This is equal to 2 NaOH. I think that you have performed. If I ask you that make a solid 0.5 m KOH, how will you perform? The 0.5 m KOH, the molar mass of the KOH is 56. So 0.5 into 56 is equal to 28 gram per liter. You will dissolve the 28 gram of KOH into 1 liter to form the 0.5 KOH. So I think that your preparation of the molar solution, this is the way that how will you prepare a molar solution. Again, if you are asked a question in your examination, what is molar solution? What is molar solution? When 1 mole of the substance is 1 mole of the substance present in 1 liter of solution, that is called molar mass. So again you can say when 1 mole of the substance is dissolved in 1 liter of the solution, 1 liter of the solvent, that is called as molar solution. But the correct definition of this, that the 1 mole of the substance present in 1 liter of solution, because here volume of the solution is 1 liter. So here I think that you have understood about it. Now I have come to the second question. Dilution of the molar solution. If you have a solution of higher strength, higher concentration, how will you get a solution which is in less in the concentration or less in the strength? So here I have a question here, that is 1 m KOH solution. The 1 km solution, change the 1 km solution to 0.2 m. You have to prepare 0.2 m KOH from 1 m KOH. This is the question. So the strength, the concentration, the molarity of this solution, it is higher in molarity, it is less in molarity. So it is called as, you will add some amount of some volume of water, that this process is called the dilution of the molar solution. So what volume of, suppose it is, again I am telling you that the quantity of the 1 m KOH is 5 liter. So here, this is your, so please try to understand the question. Here it is your bottle, and this bottle has the 5 liter quantity, and this is the 1 m solution of KOH. So you have to take out some quantity to make this 0.2 m. So what quantity of this should be? Suppose now come to here, that 1 m KOH is present in 1000 milliliter solution. 1 m KOH is present in 1 milliliter of that, and you have required 0.2 m. 0.2 m. Thus the 0.2 m KOH will be present in 1000 into 0.2, that is 200 milliliter. So again, you have to take out 200 milliliter 200 milliliter of this solution, 1m solution. This is 1m solution, 200 milliliter. And now make up it to add 800 milliliter of water to make it 1 liter. 1 liter. This is the way. So here you have to say, when you take out the 20 milliliter of 1m solution and add 800 milliliter of water, that solution will be 0.2 mKOH. So I think that you have understood. I will again going to explain the same question again here with the second method. So here one thing I want to tell you, that how will you make the solution of in 5 liter quantity. In 5 liter quantity. So for 1 km, 1 m, you required 56 gram KOH. This is required for 1 liter. 1 liter. So you want to prepare a 5 liter solution. So you have to multiply this with 5. So when you find such 30 and 280 gram of NaOH when dissolved in 5 liter of water, then you will get in quantity 5 liter. So I think that you have understood how will you increase the quantity of the solution. So again, the second method to find out the volume of this km to form the 0.2 km. Suppose again I am taking this question. Again, this is your stove, 5 liter, 1 m, and this is the amount is 5 liter. This is KOH, so on. And now you have a formula that is M1 V1. It is the value M2 V2. M2 V2. Suppose this is per point. So here the M to the molarity of the 0.2 required molarity. This is 0.2 molar. 0.2 you write here. What is the amount of this solution? When you will prepare the whole total solution, what will be the amount of this solution? This is equal to the 1000 milliliter. 0.2 mKH means 1 liter. 1 liter means 1000 milliliter. So we write here M2 is 1000 milliliter. M1 for this solution, for this stove, the M1 is 1. The molarity of this solution is 1. And this V1 is the required volume from this KOH to make the 0.2 mKOH 100 liter, 1000 milliliter. So this will be right here V. Then V is equal to 0.2 into is equal to 200 milliliter. The same answer, again the same answer. So again, how will you make the 200? And this is 800 milliliter of water. This will be the 1 liter. In this way, you dilute. Dilution, how will you dilute a higher strength solution into a low strength solution, a higher molarity solution to a such type of numericals has been asked in your examination. So I tried my best to make you understand how will you dilute this molar solution. Now I am coming to the second thing, that is the molality. It is molality. What is this molality? Only a difference of pronunciation, molarity and molality. So a slight difference in the definition, a slight difference in the formula. So this is a number of moles of solute, similar. Here, volume of the solution is liter. The total volume of the liter is here. But here again think, this is molality related to the mass. Again, all I am saying you, the major difference is it is related to the mass and it is related to the volume. It is related to the volume. And here again, mass of the solvent in gram. Mass of the solvent in gram. So the molality is defined as the number of moles which is dissolved in 1 kg of solvent. 1 kg of solvent. So you take the 2 moles. Suppose you are so I will tell you the mass of the solution. Then the mass of the solution will be the mass of solute plus mass of solvent. Please remember it. The mass of the solution will increase after mixing the solute, after making the solution. So the mass of the solution will be equal to the mass of the solute plus mass of the solvent. Try to understand. And the symbol of this M and unit of the mole per kg. Here mole per liter and here the mole per kg. This is the symbol. So again, I am going to explain you a very good question. How will you change the molarity into molality? It means you want to change the molarity into change the 4 cap. Suppose here I have a question for you, the density. No, before the 4 mKOH change. See, calculate to find the molarity. 4 mKOH mole. If the density of this KH is 1.18, the density of 1.8 G gram milliliter minus or gram per liter, gram per milliliter. This is the question for you. How will you change? This question I am telling you, such type of question has been asked in your examination. So how will you change this M into M? This N stands for molarity and this M stands for molality. So how this reverse can't be, the molality can't be changed into molarity, very difficult. That is the another case. So here I am going to explain you how will you change this molarity into the molality. So here this question to change the density of 1,4M. This is, what is this? The molarity of the solution is given. The density of the solution is given. So how I calculate the molality of this solution? So again I am telling you. So here first of all it is 4 km. So here, so you have to know about the mass of the solvent, mass of the solution. You should know about the mass of the solution. First of all, you have to for mass of the solution and what amount of the KOH is dissolved in the solution. So this is the amount dissolved, the amount of KOH dissolved in the solution, that is 4M. The amount of KOH dissolved in the solution, that is in liter, that is 4M, it is equal to 4M. This is KOH. Then 4 into 56 is equal to 4 and 4, 22 for 4 gram. One thing. First of all, this 4 mKOH will tell you the amount of KOH in that solution, that is 224 gram. Now, calculate the mass of solution. How will you calculate the mass of solution? So you have a formula, D is equal to M upon V and M is equal to D into V. So here the density, the mass of, you will write here the mass of solution. I am trying to solution. What is the volume of this solution? First of all thing, the density of this solution is 1.18. 1.18. Then the mass of the solution, D is equal to 1.18. And what is the volume of this solution? What is this? This is the volume of the solution. This 4 mQH is dissolved in 1 liter. It is the volume. This 4 m. Because the volume of the solution is 1 liter. So here the solute is 1 liter. So here the volume is 1000 milliliter. Again think the mass of the solution, you will divide. So again this is the 1180 gram. So two things you have calculated. One thing, the mass of the solute and the mass of this solution. Mass of the solution 180. Then find out the mass of the solvent. The mass of the solvent. Please try to understand, don't go on my handwriting. Mass of solvent will be 1180 minus. This is the total mass of the solution. This is the mass. So you want to know the mass of the solvent. Mass of the solvent will be mass of the solution minus mass of the solute. So 180 minus 224. 224. So again, it will be equal to. Please. How will you have 224 is equal to 6 and 5 and it should be 9. So 956. 956 gram will be the mass of solvent. You have found three things, that one is the mass and second this mass. And now come to the molality, so formula of the molality. The molality, number of moles. How many number of moles are there in this solution? 4. And the mass of this solvent in kilogram. So this should be in kilogram. This mass in 956. So 956 and multiplied by 1000. Again I am telling you that 956 gram solvent contains 4 moles. 4 mole. So 1 upon 4 upon 956, and you have to calculate the molarity into 1 kg. So again you want to hear 1000 gram. So this will be the answer of your this question. You can do in this way. I have explained you how will you change the molarity into molality. So I think that both the two terms I have explained you, both the terms in this case. Again, molarity, mole fraction. What do you mean by the mole fraction? Suppose you have a solution. This is a solution and this is solute and this is solvent. Solvent. So solvent. So solute. This is solute. Suppose it is A. I define is given this is B. Suppose the number of moles of A, number of moles of A is equal to Na, and the number of moles of B in that solution is Nb. This is Nb. So it always take the number of moles of A solute or substance is Na, and the number of moles of the solvent is Np. Then the total number of solution, total number of moles in solution is equal to Na plus Nb, Na plus Nb. This is very simple, and you have to calculate the mole fraction. The number of the mole fraction, the mole fraction of A is equal to Na upon Na plus Nb, and the mole fraction of B will be Nb upon Na plus Nb. These are the mole, Nb. This is the weight, this is the mole fraction, and generally it is calculated in percentage, so you can say, you can multiply this 100, so that will be answer in your mole fraction of the percentage of the mole fraction. So you can multiply this formula with the 100, that will be the percentage of mole fraction. It was about the same. So I think that you have understood about the mole fraction. Third one, the mass percentage. What do you mean by the mass percentage? The mass percentage is very simple. Suppose you take 20 gram of NaOH dissolved in 100 gram of H2O. Mass percentage. You have to calculate here mass percentage. 100 gram of H2O. So what is the mass percentage of NaOH in that solution? Now the mass of the solution. No, you have. It is not. You will concentrate the 20%. No, that's wrong. You will wrong. Mass of the solution is 100 plus 20. 20 gram of NaOH and 100 gram of H2O. So 120. 120 is the mass of the gram, is the mass of the solution, and then in 120 there is a 20 gram of NaOH. So the percentage of the NaOH will be 20 upon 120 upon into 100. This will be the, so you can say 6, 53, 50 by 3, and you can say 17.3 or so on. What will be the answer of the? In this way, you can calculate. This is the mass percentage. This is the mass percentage of the solute. So that's all for today. I think that you have understood. Please don't go to my handwriting. Listen to my way of teaching. Listen to my the intention to make you understand. So I think that you have understood this whole molarity. Keep watching my video. I will give you so many numericals about this molarity, mole concept, and mole fraction and mass on. So that's all for today. But one thing I want to say you that please like it, share to your friends, to say at least you should share your 10 friends to motivate my teaching. And if you have any suggestion to improve my teaching, I am very happy to accept your suggestion. So that's all for today. Thank you very much.